Thanks. Yeah, I'm happy because we have at least one non-Polish speaker. That's Nabil, that also lives in Berlin, and uh, he came for ElixirConf EU. That was 2 days ago and yesterday. Mm, and yeah, let's start. Boring Ruby code. So, what are the features of boring Ruby code? When code is boring, it's easy to understand, it's easy to read, and you spend most of your time as developers reading code that somebody else wrote, not writing new code. And it's also easy to delete. If it's boring, then you don't have attachment to the code. So like it's nothing special. I can delete it. And that's a very important property. So these were the most important points. Now I can make some like more relaxed part, and then we will continue. So I'm really, really sad that we don't have Toby with us today. He was supposed to speak at ElixirConf EU as well, but he got sick and couldn't come. And Toby is a great speaker. He also organizes Ruby User Group Berlin, but I'm really thankful for that. Maintains a few Ruby gems, including SimpleCov that I'm sure that many of you use. Has his own library for performance testing in Elixir, and is also my colleague at a company called Lifery. That's a small startup, say smallish startup, but it's based in Berlin. And yeah, we are constantly hiring. So if you consider moving to Berlin, you can let me know and talk about it. I think it's an interesting opportunity. So I put some nice pictures of Berlin to encourage you to move there. Yeah, sometimes it looks a little bit gloomy, but it also has nice street art, including more politically involved street art, and yeah, some techno culture, which sometimes it's a bit difficult to understand, but yeah, it's fun. So this whole talk will be about good code, and yeah, you have to remember that like good code is very subjective. So I will show some examples and things and patterns that I personally consider a good idea. But of course, like depending on like your particular company and the team, it may be more or less applicable. And the structure of this talk is following. I will have a lot of examples of code that tries to be smart. So we will see these examples, and I will talk about a little bit about every one of them. I don't expect to have a lot of like impact with them. It's primarily to look at these code examples and laugh a little bit at them, because programmers love looking at code that was written by somebody else and is overly complicated. Somehow it gives us this weird pleasure that's, oh yeah, that's like such a contrived example, but at least it wasn't me who wrote it. So that's That's the basic idea of this talk. And all code examples are taken from GitLab, which is an open source project, and I took it for a few reasons. First of them is that I was working for GitLab, the company, so I feel some kind of responsibility for this code, and I'm not picking on somebody else's code. I was like also responsible for this code. And it's because it's an open source project, then like it's possible to find this code. Either like it's still there, I haven't checked, or it's in the history. So you can verify it. And let's start with an innocent example. So we have an constructor, and we have to assign a bunch of values. And instead of doing it line by line, we have a loop, and we iterate over an array, and we use send. And by the way, I have some nice colors in the slides to highlight the important part. So that's, yeah, you'd say that that's nothing, right? That's looks okay. Yeah, we can live with that. And then we move to a next example. So here we have a list, an array of 3 method names. We iterate over the array, and we use define method to dynamically define these methods, and we use send to call a specific one. So let's take a look how it would look like if we try to implement a boring version. So that's the boring version. We define 3 separate methods. They look kind of similar. Okay. And let's look at the smart version now. That's so much more dry. We are very, very dry. And yeah, let's continue on the same note. Here we have now 2 method names in the array, and we have defined a method. But if you look a little bit closely, this whole blue part is the same. It doesn't depend on the method name. So what we have here is at the beginning we have some transformation on the argument, but doesn't depend on the method name. It's always the same, and then we call super. So again, the boring version of this code looks like this, right? We were so focused on our shiny meta programming skills, but we forgot about like the most basic tool in our programming toolkit: extract method pattern. So now it's a little story time, and for that I have a really great stock photo. One day I would like people to look at me as the people in this photo look at the guy in the middle. That's, yeah, he's amazing. So my story starts here with this line of code. I started with I was working on the GitLab code base, and I noticed this line of code, and I wanted to find the source of authorized download code, so I can understand what's doing, because the name seems pretty obvious, but as we are debugging stuff, we want to know how stuff works. So I fire up my text editor, And of course, we are in a dynamic programming language. So when we want to find a method definition, our first choice is a search across the whole code base. And by the way, I also use a boring text editor. So I use Sublime Text, which I believe is it's very lightweight, simple, and boring solution. And yeah, this may make me some enemies here, and maybe I will not get any more free drinks. But I strongly believe that in the war between Emacs and Vim, Sublime Text is the winner. Ooh. So going back to the story, I fire up my text editor, I search through the code base, and then a very scary thing, no matches. We cannot find the definition of the method. Where is it defined? I think I spent like 30 minutes, maybe an hour, searching for it. And in some controller 2 layers of inheritance above, I found this. And I highlighted the important parts for you. So we have a method missing, and we pattern. So we do a regex match on the method name, and if it matches authorize underscore and then bang at the end, we call a different method. If not, we just continue. So that looks like somebody playing hide and seek with me, trying to hide this on purpose. It costs time. Let's continue on the method missing node. So here we have method missing. We have send. That's kind of okay. But look here. Here we are comparing the method name with a constant, right? So in method missing, that is meant to handle a method that is not defined. We are checking if the name of the method equals lookup. I have no idea what's the point of this code. Apparently, just defining the lookup method was a too boring choice. I don't know. That's definitely confusing for me. And the important thing to notice here is that this code looks smart. It's method missing. It uses send. It has this block given. It looks kind of scary. So people are less likely to question it. People will look at it and assume that, okay, it looks smart. So somebody had an idea when they were doing it. And this code tends to stay. Okay, let's look at another example of method missing. So we have method missing, we have send, we have yield, we have block given, all this kind of stuff. But let's look here. Here in method missing, we are checking if the object responds to the method that is missing. This code was there. Everybody was looking at it and not questioning the existence of it. Like, yeah, looks fine to me. But at least our test coverage showed that whatever comes, basically the first line always returns. So the next lines are not covered. Maybe there exists some edge case that this makes sense, but I haven't found it so far. And even if it exists, it still doesn't justify the complexity of the code, because any programmer looking at this code and trying to understand it will be confused. I have no idea. Yeah, it it may have some explanation, but I think that's just trolling. We also have different ways if we want to make something more obscure. For example, we can redefine a square brackets operator on a module. That makes it super hard to search across the code base and figure out what's going on. Yeah, please don't redefine this operator. And let's talk about a code that tries to do a little bit too much. So we have a snippet like this, and as you can see, it accepts project ID as an argument, but our project ID doesn't seem to always be a project ID, because it can be a project ID or it can be an instance of project model. So we are trying to handle too many cases here and somehow patch up our wrong abstractions. Oh, oh, okay. And we have more contrived examples. Here we have a method where we have one argument target, and we check the methods that it respond to, and then we check its class. But also, what's important here is that we have a call to another method, and if we take a look at the definition of this method, we will notice that it also includes a bunch of type checks. So my conclusion here is that once you start introducing this kind of code where you use respond to or you check for the type, it will spread across your code base. It's difficult to keep it localized in one method or one class. It tends to spread across the code base, and it's usually a sign of a bad abstraction. So we can do it. We have the power to do it, but I don't think that we should. And this can also lead to problems like here. So here we first check if a certain value responds to map, and then we pass it to another class or not. So, but what's the meaning of this map here? We are checking something that should be responsibility of the class that we are passing it to, because why should I care about map here? I have no idea. And we can also have code that poses some existential questions. It's just enough to read it with an appropriate voice. So if note is a note, isn't it like to be or not to be? But apparently note can also be something else than a note. So let's recap. Boring code is easy to understand. You don't have to spend a lot of time thinking about it. When you read line by line, and every single line is easy for you to understand, then you don't waste your you don't waste your time. And when it's the important thing that boring code is also easy to read, and we spend most of our time reading the code. So we first tend to read the whole code around the feature that we want to modify, and then maybe we will change 2 lines or 3 lines. That's very often the case for me. So optimizing for something that is easy to read really makes sense. If you write 10 lines instead of 2, you will do it once, but then you will continue to read this code over and over. And if these lines are simple to understand, it will benefit in the future. And it's also easy to delete, because you saw examples of code that looked smart but contained very obvious bugs, or just things that didn't make sense at all. But this code was there. People were looking at this code and people were assuming that this code is smart, so this code makes sense. And when you use metaprogramming, you use some obscure Ruby features, then you can be proud of yourself that, okay, that's so advanced. But in fact, you develop too strong attachment to your code, which makes it hard to delete. And that's it. Thanks.
So, are there any questions? And if you're more comfortable asking in Polish, then feel free to.
How often did you use Git blame?
On this, I think I try to avoid using Git blame to find a person that introduced the code. I was more interested like when it happened, and in many cases this code was there for like a year or 2 years. So like it wasn't a thing that was introduced, I don't know, like 2 weeks ago, because it somehow passed the code review. But these were things that were in the code base for a really long time. So I assume that people were just looking at it and like kind of going through it, and okay, yeah, that it's there, looks complicated, makes sense. Yeah, let's just go to another file.
Thanks. I have one more question. You're now working in Elixir, and after the experience with a huge Rails, or Ruby at least, code base, and now moving to Elixir code base, do you find like fewer places like this in Elixir, taking into consideration that it's probably a smaller code base? I don't know about Livery, but like I would imagine it to be smaller just by the sheer, like I assume GitLab is just huge.
So we at Livery we have two Elixir projects, but we still primarily work on the Ruby code. So our Ruby code base is much bigger, and no, so far I don't have anything interesting to compare in like between Ruby and Elixir. So I didn't find the same things in the Elixir code, but like also these applications were created later, also with developers that had like more experience or didn't have to rush that much, so I wouldn't compare them.
Okay.
What about the benchmarks of the simple code or boring code and the metaprogramming code?
I usually I have a strong opinion on benchmarking, and which basically says that usually in like a 3-4 years old code base, you have a lot of places that you know that you have to optimize, and it's usually places where you have 100 SQL queries to generate a single view, and these are the bottlenecks. So I don't usually measure the performance of like small code snippets. I basically think that it doesn't matter in big applications.
Okay, thanks.